All right, here in 6.1 part 2, we are going to take a look at how to solve trig equations using a calculator. In other words, we'll be solving for an angle that we haven't memorized. So it's not going to be one of your standard 30, 45, 60, or quadrantal angles. Okay, so take notes. Make sure you are checking in for attendance online. Okay, so 6.1 part 2. Okay, so using a calculator. All right, so the one thing you definitely want to make sure is that you are in the correct mode. So let's make a note of that. So if we're dealing with radians, make sure you're in radian mode. If you're in degrees, if the problem is in terms of degrees, then make sure you're in degree mode. Okay. And then also here, I would really recommend that you draw your quadrants so that you know what angles you want. Okay. All right. Because it can get a little messy. These are a little more involved than the ones that we just did in the first video. So keeping track of, okay, I need to have these quadrants, because remember when you use the inverse trig functions on the calculator, they only give you very specific values, right? Like sine will only give you from negative pi to pi, right? Whereas cosine, so angles from here to here, right? So if you want an angle over here, you're not going to get that on the calculator. So that's why it will be helpful if you draw the quadrants. And then same thing with cosine. It'll only give you angles from 0 to pi, right? So from here and here. So if you need an angle that's down here, you won't get that on your calculator. Okay, so you'll have to figure that out on your own. Okay, so definitely draw quadrants. Okay, so let's take a look here at this first example. Let's go ahead and solve 7 minus 8 sine. And this part is new. You haven't seen anything added or subtracted to the angle. So x plus 3. In the previous examples, in the first video, we only had an x. Okay, so having this plus 3 just adds a little more complexity to this solving process. Okay, but not that much more. Okay, so solve this. If it just says this, then we'll have to tag on the plus 360 degrees n if we're in degrees, or we would have to do the plus 2 pi n if we are in radians. Okay, all right. But it's not going to be that kind. It's going to have this restriction. If your angle x is between 0 and 2 pi. Okay, so last time it said 0, 360, so we knew we were in degree mode. But because it says 0 to 2 pi, we know that we are in radian mode. Okay, so kind of make a note of that. Because if you start doing all of this without, where did it go? All right, if you start doing this without, look at that, it's not working. Okay. All right. Well, I can't change colors now. All right. Anyway, so so over here, this means radian mode. Okay. Okay. If that were in degrees, then of course you would be in degree mode. Okay, so let's go ahead and bring this down here. 7 minus 8 sine x plus 3 equals 10. All right, so same as before. We want to get the trig function by itself, so I'm going to subtract 7. Negative 8 sine x plus 3 equals 3. Divide both sides by negative 8. Okay. They cancel out. So we get sine x plus 3 equals negative 3 over 8. Okay. All right. So here, now we can go ahead and use our sine inverse on the calculator. So here we would do sine inverse of negative 3 over 8. Okay. Again, make sure you are in radian mode. Okay. So when I punch that into the calculator, I get negative 0.38. All right. Let's draw our quadrants. Okay. So up here, okay, so I want to know where the sine is negative 3/8. So that means we're going to be somewhere in here and in here, okay? And don't forget this restriction. We are from 0 to 2 pi, so the smallest our angle can be is 0. Okay, so we can't have any negative answers, but we got a negative result here, okay? Which tells me at least what the reference angle is going to be for these two. Okay, so this tells me that the reference angle is positive 0.38. Again, it's radians. Okay. All right. So if I want this angle here, right? This is the quadrant 3 angle. Okay. So let me go down here. So for my quadrant 3 angle, I'm going to do pi plus the reference angle, which is 0.38. Okay. So here I get roughly 3.52. Again, radians. Okay. You don't have to put the rad. All right. For the quadrant 4 angle. Okay. So up here, let me erase this. So now I want the quadrant 4 angle. So I'm going to go all the way to here, right? That's the angle that I want, this one in quadrant 4. And so this is going to be just shy of 2 pi. So it's going to be 2 pi minus 0.38. Okay. And so when I do that, I get 5.90. Okay. We're not done. Okay, so those are the two angles. And so that tells me, again, here with the plus 3, that adds a little more complexity to this problem. So, so we know this. Let me explain why we have to do this extra step here. So we know that the sine of 3.52 equals negative 0.38, right? And we also know that the sine of 5.90 is equal to negative 0.38, okay? But we don't have x. This is not just x. When we look at the original problem, it's x plus 3, right? So here, this tells me that, oh, okay, x plus 3 must equal 3.52. this tells me that x plus 3 must equal 5.90. And now we have to solve for x. Okay? So if I subtract 3 here, both sides, I get x is equal to 5.52 radians. And then over here, if I subtract 3 here, then I get x is equal to 2.90 radians. Okay? All right, and we see here x has to be somewhere between 0 and 2 pi. 2 pi is 2 times 3.14, so somewhere between 0 and 6.28. And we see here that our two answers are between 0 and 6.28. Okay? All right, so let's let me have you guys try one of these. I won't have it have an x plus 3, so I'll give you one that doesn't have that extra step there. But go ahead and see if you can figure out this process here for this next example. Okay, so try this one. And then we'll see if your answer matches mine. Okay, so solve 3 sine theta minus 2 equals 7 sine theta minus 1 if 0 degrees theta 360. Okay, so we do have this restriction, so we're not going to do that infinitely many solutions using the plus 360k or 360n. Okay, so we just want the two angles that are going to be in between 0 and 360. All right, so go ahead and hit the pause button and come right back. Okay, so I'm going to go ahead and write it down over here. 3 sine theta minus 2 equals 7 sine theta minus 1. Okay, so I am going to subtract 3 sine theta. Okay, so I get negative 2 on the left, and I get 4 sine theta minus 1. I'm going to add 1 to both sides, and I get negative 1 equals 4 sine theta. And again, here, this part right here means calculator should be in degree mode. Okay. Where am I? 4 sine theta, negative 1. Okay, so divide both sides by 4. Negative 1/4 equals sine theta. Negative 1/4 is between negative 1 and 1, so that's good. Okay, so here, that tells me that I want the angles where sine is negative. So that would be here and in here, okay? And it has to be somewhere between 0 and 360. Okay, so use the calculator. Make sure you're in degree mode. So when you do this, you're going to do sine inverse of negative 1/4. And when you punch this into your calculator, you should get negative 14.5 degrees. Okay, so again, this tells me the reference angle is positive 14.5. Okay, so up here, I want the angle that's in quadrant 3, and I want the one that's in quadrant 4. Okay, So quadrant 3, let's start with that one. So we're going all the way around here. Reference angle is 14.5 degrees, and this is 180. So 180 plus 14.5, and that will give me 194.5. And then my quadrant 4 angle. Okay, so I'm going to go ahead and erase this, erase this, erase this. All right, so I want this one over here, and it's just shy of 360 degrees. Okay, that looks like 366. Okay, it's just shy of 360 degrees. How shy? 14.5 degrees shy. Okay, so then I'm going to do 360 degrees minus 14.5 degrees. Okay, and that is going to give me 345.5 degrees. And since I don't have an x plus 3 like I did in the other one right here, then I can stop. Okay, so theta equals 194.5 degrees. That's one answer. And the other answer is 345.5 degrees. Okay. All right, so that is it. If we did have something like x minus 5 in here, then you would have to do the extra step of doing x minus 5 equals 194.5, 194.5, and then solving for x, okay? But we don't. We just have a theta in there. Nothing added or subtracted or even multiplied, so this is where we can stop, okay? All right. If you have any questions, make sure you email me or text me. Don't forget to check in for attendance.